Okay, now we're back to the first question, example 1. Okay, so let's read the question first. So first of all, a metal wire is 2.5 millimeter diameter and 2 meter long. A force of 12 Newton is applied to it and stretches 0.3 millimeter. Assume the material is elastic. Determine. Okay, the first question is gonna ask the stress in the wire, and the second is the strain in the wire, and the third is the Young modulus inside the wire. Okay. So first of all, let's track all the information given inside the questions. Okay, now we have a metal wire, a 2.5 millimeter diameter. Okay, and we have 2 meter long. So we know that this is diameter. This red pen here. So this is 2.5 diameter and 2 meter long. So this is your initial distance, or like the actual distance. A force of 12 Newton is applied. So kita ada kat sini adalah forces 12 Newton. Okay, and stretches to 0.3 millimeter. So when we say stretches, so we means that elongations. So it's gonna be the E, elongation. Assume the materials is elastic. Determine. Okay, the stress in the wire. So we know stress formula is gonna be F over A. So the force divided by the cross section, the area of the cross section of the wire lah, in this case, and F the force and perpendicular to the cross section. Okay, and then the second question, the strain in the wire. So we strain is equals to elongation over L0, the actual distance, the actual length, and the Young modulus is equals to Y is equals to stress over strain. Or you can say, after we multiply everything, it's gonna be F times the actual length divided by the area times the elongations. Okay, right now at the moment we don't have the A yet. We don't have the cross section area yet. So we know that A is equals to, because it's a metal wire, so below cross section there, the last is gonna be pi r squared. Circles lah. So we don't have the radius, or we do have the diameters. It's 2.5 millimeter. So biasakan dalam kelas saya 2.5 millimeter ni kita tukar pada SI unit dahulu. So we have the 2.5 here. So in meters is gonna be times to the exponent -3 meter. So this is length in this diameter in SI unit meter. So we have the pi. So radius is gonna be half lah. So 2.5 to the power of -3 divided by 2 squared. Therefore, you will get A is equals to let's say we calculate this one. Okay, now we can calculate the stress. We already have the force as well here, F. Okay, so the first question is gonna be stress F over A. So F is gonna be 12 Newton over the area is gonna be pi 2.5 times to the power of -3 over 2 squared. Therefore, we get the answer in 2.44 megapascal. Okay, this is the SI unit for stress. We use Pascal in this one. So answer the first question. Okay, let's move on to the second questions. Okay, on the second question, is asking for the strain. So we know that the strain is gonna be, the formula is gonna be E over the actual distance. So the elongation we have just now is 0.3 millimeter. So we turns to SI unit meter over the actual distance gonna be 2 meter long. Therefore, we get it. The answer is gonna be 1.5 of 10 negative 4 unit. No, there's no unit for the strain, because the strain is actually just the ratio between the elongation to the actual length. So it's just a ratio. If you say about ratio, we don't have anything unit to be with it. Okay, so answer the second question. Okay, for the third question, it's asking for the Young modulus. Okay, so we know that y is equal to stress divided by strain. Okay, or we can also equal to F forces times the actual distance divided by area times by the elongations. So we have all the value here, or we can just divide it by the value that we have just now. So we have the strain is values is 2.444 megapascal over strain. It's gonna be 1.5 times to the power negative 4 without units. Therefore, we get the answers is 16.67. Let me just get the calculator for a moment. Mega divided by 1.5 exponent negative 4. Okay, therefore we get the 1.623 to the power of 10 Pascal. Therefore, why Pascal is the SI unit for the Young modulus is gonna be Pascal as well, because if you can see from here, there's no unit for the stress for the strain, but we do have the unit for the stress. Therefore, we cancel out. It's gonna be, there's nothing unit here, so it's gonna be same unit, PA, Pascal. Okay, answered. First question. All right.